Hello, and welcome to Saturday's edition of Cracking the Cryptic, where we are going to do a follow-up video to yesterday's video, in which I covered Big Tiger's sort of inaugural Battlefield Sudoku puzzle. Hopefully I've made his year. And anyway, well, he inspired a lot of imitators. And we've already covered a couple of those imitation puzzles, one by Nylin, one by Christoph Seeliger. And today we're going to do one by Carrick22. Carrick22 is not a pseudonym I recognise, but this puzzle has hugely good plaudits on Logic Masters Germany, and our testers raved about it as well. So I'm very much looking forward to trying it. And it is using a variation on these Battlefield Sudoku rules. In fact, Carrick22 calls this puzzle Killer Battlefield Sudoku Enigma, which is a right mouthful. So I'm going to just call it the Enigma Variations, because I think that's, well, it's just such a beautiful piece of music, and it evokes, therefore, great things. And if it's a great puzzle, that seems a fitting title. Now, what are the rules? Let me tell you. We have got, well, firstly, we've got Battlefield Sudoku rules. So if you are not familiar with those, time to concentrate. What we have to do is to consider the first X cells and the last Y cells of a row or column, where X is the number in the first cell and Y is the number in the last cell. So the best way of thinking about this is with an example. Let's look at row 7. Let's imagine that square was a 4. Let's imagine that square was an 8. So we have to consider the first 4 cells, because this square is a 4. And from this side, we take 8 cells, so that reaches to here. Now you can see if we compare those 4 cells and those 8 cells, they overlap in these 3 positions. And in this variant of Sudoku, this HJ clue will give you the sum of those 3 cells. Now if, on the other hand, let's pick some different numbers. You have a 2 here and a 3 here, for example. You can see the 2 reaches 2 cells, the 3 reaches 3 cells. These lines don't meet each other this time. There is a gap in the middle of the row. If there is a gap, what the HJ is giving you is the sum of the cells in the gap. And as we saw in yesterday's video, one way of thinking about this, which some people find helpful, is to consider Big Tiger's sort of original framing of the problem, which is that there are 36 armies all advancing on each other. So each army from this side is advancing from left to right. Each army from this side is advancing from right to left. Each army from the top is coming down, from the bottom is going up. And then these clues are telling you basically the sum of the casualties. If these armies meet and they overlap each other, then this is giving the sum of the casualties. If they fall short of each other and they don't reach each other, it's giving the sum of the casualties avoided. And it's quite a nice sort of way of thinking about the puzzle. But it, unfortunately, in terms of fitting in all of the army stuff to the right-hand side of the grid, no, we just can't do it. So we're sticking with a rather less poetic version of the rules. Now, a cell is coloured red if it's part of an overlap in its row and in its column. It is green if it's part of a gap in its row and its column. So again, you can see we've got some green and red cells here. So let's think about the greens first. So this is saying that from this direction, from the top direction, the army coming down here never reaches this square. So in fact, this cell is very restricted immediately. It could only be a 1 or a 2, because if it's a 3, the army would reach this square, which the green cell is telling us it cannot. So in fact, the greens are causing a restriction on those 4 cells. Let's delete those 2s and 3s before they confuse me. Now red cells, they have to be overlapped. So I don't know, let's look at the central square of the grid. We can know that these 4 cells here each have to be at least equal to 5, because the armies coming from all of these directions have to always make sure they at least get to this square. So yeah, there's some reds and greens going on. And then finally, we've got the encrypted part. So in this puzzle, all clues are encrypted, hence the Enigma title. And each letter from A to J must be paired with a number from 0 to 9. This is why I've had to do a sort of bigger version of the grid, is because actually 0 is one of these digits or one of these letters. So I needed 10 different rows. Different letters encode to different numbers. The number AB represents the number for which A is the tens digit and B is the units digit. It does not mean A times B. So if HJ was equal to 23, if H was 2, I should say, and J was 3, then HJ would be 23. It would not be 2 times 3. It would not be equal to 6. So there are a lot of rules there to learn, and some of you I know don't like complicated rules. Some of you absolutely love complicated rules. But what we always try and do is to, balance out the rules with the quality of the puzzle. So if we had a very ordinary puzzle with a very complicated rule set, it probably would never appear on Cracking the Cryptic. But if it has complicated rules and it's a brilliant puzzle, happy days, we will go ahead with it. So that's what we've got today, the Enigma Variations by Carrick22. If you want to have a go at it, click on the link under the video, as usual. And with that, I'm going to have a go. Let's get cracking. Now, how do we get cracking? We have to go with what? Well, actually what I might do is start with the green squares then. So this cell can never reach the green square, so that's got to be a 1 or a 2. This square's got to be a 1, 2 or a 3 because it can't reach this square. This square's got to be a 1, 2 or a 3 because it can't reach this square. This square's got to be a 1 or a 2. It can't reach this square. So that square's got to be 1, 2, 3, 4 or 5. 1, 2, 3, 4, 5 or 6. That one's got to be 1, 2, 3, 4 or 5. So we can get a little bit of restriction on some of the cells around the grid. Now let's do the same with the red cells then. Actually, oh yeah, the red cells from this side are very, so this is very good, these two cells, because we've got to get at least up as far as row 2 of the grid from here. So we know that both of these squares have to be at least equal to 8. Well, they can't both be 8, so they must be an 8-9 pair. One of them's going to go all the way up, the other one will stop in row 2. These squares are essentially unrestricted. That square's got to be an 8 or a 9 as well, because it's got to get at least to column 8. These 4 squares around the grid have got to, well, they've got to be at least equal to 5. But this one's got to be at least equal to 6 because it has to get to that one. Okay, now is this helpful? It would be helpful if we knew what H was. Yeah, look, we can restrict H because if we look round the grid, look at the clues for the rows. We have JE, CG and HJ. So in Battlefield Sudoku, you can never have a clue that's bigger than a 30 number. And you can see that if we just, let's think about it. What's the biggest overlap we could possibly create in one of these puzzles? Well, it would be a 9 here and an 8 here. That would give 9 cells this direction, 8 cells from this direction. So that is an 8-cell overlap. Now, we can do some arithmetic to work out the size of the 8-cell overlap because we know that the row will contain all of the digits from 1 to 9. 1 to 9, if you add them up, you get 45. So if I just take an overlap equal to those 8 cells, we know it's just equal to 45 minus 9, which is 36. So the biggest overlap you can create in Battlefield Sudoku is 36. Now, there is a weirdity about this puzzle though, because you can create bigger underlaps. So if you try a 1 here and a 2 here, I think you get a yeah, you do. You get 39, don't you? Because this square just takes that cell, the 2 takes those 2 cells. So this time we're summing those 6 squares, and we can make them as big as we can. So we can hide the next smallest digit in this square, and we're summing up 4, 5, 6, 7, 8, and 9. Well, that is equal to 39 because that's 45 minus 1 minus 2 minus 3. So all of which is a very long way, or very long-winded way, of saying that J, C, and H are the numbers 1, 2, and 3. So we get to populate the right-hand side with some options. Oh, Now in fact H is 1, look. And we can see that because we've got killer Sudoku cages here. I didn't actually go over those in the rules, but hopefully you're all familiar enough with killer Sudoku. So these squares here, we can't make a 2-digit domino add up to more than 17, because the maximum we could put into them would be 8 and 9. So H just has to be 1. In fact, that's been sitting there from the start, I think. Now, can we do more, therefore, with this clue? So this clue is an overlap clue, and it's overlapping in exactly one cell, because we know that the H is a 1. But we know that... yeah, okay. So there are 2 ways we could organise this row, and in fact the red cell here is disambiguating those 2 ways. One way would be that this was a 9. Now if this is a 9, it reaches the whole of the way up the column. So in order to have a 1-cell overlap equaling with a 1 in it, I have to put the 1 there. Now that would ordinarily be okay, but not in this version of Battlefield Sudoku, because the army coming from this direction has never reached the red cell, which it must do. So this doesn't work. In fact, therefore, this must be 8. It reaches this square. This is where the overlap occurs, therefore. So that's a 2, and therefore the overlap is in this square, which is a 1. Oh, that's a 3 now, look, because it can't be a 1 or a 2. Oh, that's a 1, that's a 3. That's not a 3. That's not a 3. And actually we've got quite a lot of well, quite a few digits in the grid as a result of that straight away, which is lovely. Oh, I just had a thought then. Maybe I should be thinking about which of these digits can't be 0. Because D can't be 0, because it's A can't be 0. E can't be 0. G can't be 0. Oh, no, I think... So that's 4 other digits that can't be 0, but that's not enough, is it? There's still 3 possibilities for which is the 0. I could be 0, because you can have a 0. If this was a 5, for example, and this was a 4, the army from this side gets to there, the army from this side gets to there, and they meet each other, but they don't overlap, and they don't underlap. So this clue would be a 0. So I could be 0. Oh well, I'm not sure how to take that forward. So I think we should look for other things. So H is equal to 1. So this square is HC, which is equal to 12 or 13. No, that's no use. JE? No, I don't. HG. Oh no, actually, this cage is seriously restricted. HG has a maximum value of 19, but these 2 squares have the minimum I can make those 2 squares is 4 and 5, because I've already got 1, 2, and 3 in the row, and I can't make this square a 1 because there's a 1 in the row. The minimum I can make that square is a 2. 2, 4, and 5 add up to 11. This has a minimum value of 8. 11 plus 8 is already 19, so I need this to be populated with its absolute minimum values. That gives me a 2 and an 8 in the cage, and HG equals 19, so G is a 9. That's not a 5 now. 2 must live in one of those squares. This is not 2. In fact, this has to be a 1, because it can't be a 4 or a 5 either. Ooh, now let's have a look. So this is CG. So this is either 29. Oh, well, we know what this is, because it's either 29 or 39. But look, there's a 3 and a 1 and a green in the row, so we know it's an underlap clue. The maximum size of an underlap clue, we've looked at it already, is 39, and the only way of constructing that is with a 1 there and a 2 there. A 3 here is no good, because it's losing those squares. We only get a 5-cell underlap, so we can't make this 39. It's impossible. This has to be 29, and that means C is 2. Oh, it makes a lovely change, this, that I'm actually getting some digits in the grid. You know, several videos recently, if you've been following the channel, have involved me just staring at grids for 5 to 10 minutes without entering in a single digit, sometimes not even a single pencil mark. So yeah, this is fine. So this is 29. So if this is 29, those 5 squares are adding to 29, 30, 33. These add up to 12. Oh, so we can get, oh yeah, we can get CF. If these add up to 12, 12 plus 6 is 18. These squares must be 27, and F is 7. This is going remarkably well. So F is equal to 7. JE is therefore a 30-something number, and it's at least equal to 34, because 31, 32 and 33 are impossible. So if this was a 7, 8 and 7, there would be an overlap of those squares, and I would be missing out 7 plus 2 plus 8 from the total, which is 17, which is 28 would be the maximum. So this has to be a 9. And if this is 8 and 9, therefore, we're overlapping all of the squares apart from the 9, and this is 36, therefore E is 6. So E is 6 in this column. Oh, E is 6 here. So this is either 1, 5 or 2. Oh, that's lovely. Yeah, look at this. This is either 1, 5 or 2, 4. But this square, this army from this direction has to reach that square. So this has to be a 5. It can't be a 4. It won't get there. So that's a 5 and a 1. Okay, so got 12 here. This, what was this? 27. So there must be a 6 in one of those 3 squares, because we can't put a 6 in one of those 2, because otherwise we'd have to put a second 6 in. HC, we now know HC. HC is 12. That's not helpful. G is 9. HA. I don't know what A is. What are the options here? We've still got to place 0, 4, 5 and 8. Yeah, so we can get A, because, yeah, A is 8, because A can't be 5, because 1, 4 and 2, 3 are impossible in the row. A can't be 4 for the same reason. 1, 3 is ruled out. A can't be 0, because it needs to be positive. So A is equal to 8. And it can't be 1, 7 or 3, 5, so it's got to be 2, 6. Oops, I didn't mean to do that. Let's get rid of that. 2, 6. Oh, this 1 means that's a 2. That's a 6, therefore, because this is A as well. That's not 6 or 8. So, okay. So maybe I've got to use... Oh, JG is 39. So this column is a maximum underlap. Given this is a 1, we already know it's... Well, given the options here, we know it's an underlap. 39 is the maximum underlap, so that's a 2. This is a 3, therefore, in order that we can create 39 in the column, in those 6 cells. Threes, we can do a little bit of Sudoku. Threes get locked into one of those cells. CE is equal to 26. Oh, well, that's good. 26 with a 3 means the other 3 cells have to add up to 23. They have to be 6, 8, and 9. 8 can only go there. 9 can only go there. These are 3 and 6, and we get to place everything. This square now must be a 5. Ah, this square must be a 7. It can't be 5, 6, 8, or 9. That's a 7. So this square... what am I doing? This square's got to be a 1 or a 4. This square's got to be a 1 or a 4. And E is equal to 6. But we don't yet know the value of this square, do we? So this is CF. CF was 27. No, I don't know how to do that yet. HF. What's HF? HF is 17. Oh, HF is 17. That's just an 8-9 pair. Bother. This is so... There's one of the hard things about this puzzle is there's a lot going on, and until your brain actually, you know, looks at the things it's meant to look at, you can leave great gaps in the solving that would be helpful. So now you can see with 6s, look, we need to put a 6 somewhere in column 6 of the grid. It can't go in those 3 squares there, so it must be, in fact, it must be in one of those 2 squares because of the 6 there. This can't be a 9 now because of the 9 here. These squares have got to be 6, 7, and 9 in some order. So the 6 is in one of those 2 places. The 9 is in one of these 2 places. There's a 9 in one of those 2 squares. And I've still got 0, 4, and 5 to resolve. So if D is not 0, so D is either 4 or 5. This is either 3 or 4, which... Ah, and it can't be 3. So D is 5, I think. D is 5. So I now is either 4 or 0. Ah, and I can't be 0 because, look, we've got a 3 at the bottom of the grid. So in order for I to be 0, this would have to be a 6. It would have to exactly meet its counterpart on the other side, which it doesn't. So I must be 4, and B is 0. Now I can't put 0 in, unfortunately, so I'll make B grey to indicate that B is 0. So this is saying, so I is 4. So if this was a 4, yeah, you can't do it. Those 2 squares then would have to add up to 4 themselves, and you can't put 1, 3 into them. So this square is a 5, this is a 4, this is a 4 because we need 4 to lie in the gap. And slowly I'm getting there. I know it's not efficient, but I am making progress. Now I've done the JG clue, I've done the H clue, I've done the I clue now. I've done the JE clue, the CG clue. Oh, no, I need those 2 to add up to 12, didn't I? Which still is possible to be... I still don't know how that looks. Okay, so HJ is equal to 13. Wow, that's completely impossible. A is equal to 8. Ooh, A is equal to 8. And in fact, HA is equal to 18. Ah, here's something. HA is equal to 18, and it can't have a 3 in it. Now, those 3 squares need to add up to 9. Without using a 3, we can't use 1, 3, 5 or 2, 3, 4. So the only option left is 1, 2, and 6. And that square, therefore, must be a 1. This is a 2, 6 pair. There's a 1 in one of these 3 squares. The 2, 6 pair disambiguates the 4, 6 there, look. That gives us the 6 and the 2. Plonks a 2 into the centre of the grid. The 4 means there's a 4 in one of those 2 squares. Those 2 squares have got to be 5 and 7 to complete the row, but we can't resolve it yet. Oh, although HC is 12. So now this has to be 3, 9, because it can't be 5, 7, it can't be 4, 8. So that's 3, 9. That's not 9 anymore. 3 must be here by Sudoku. Oh, this square's 6 by Sudoku now. And we can see that looking at column 8 and 9. Look, we've managed to lock 6 into box 3 and box 9 in the same columns of the grid. So as we scan down, we know 6 is not here, it's not here. It must be here, that's the only option. Therefore this is 6, assuming my pencil marking is okay. Okay, so what now? So I've done H. Oh, I was looking at A, wasn't I? 9. Oh, okay, this is resolved, look. This is going to give us this 2, 6 pair, because we know 9 comes to here. If this is a 6, it's an enormous overlap that apparently has to add up to 8, which is clearly going to break. So this must be a 2, and you can see that works beautifully. That creates the 6 here, gives us a 6 at the top. There must be a 2 in one of those 2 squares. G is equal to 9, which can't be 3, 6, we can see, but I'm not sure how much further than that we can go. And we know that that's got to be a 4 now. Maybe that's going to help. No, that doesn't really help. Okay. So let's have a look down this column then. 3, 5 and 6. That's got to be a 5 or a 7 because there's a 3 in the row. So 3 gets shunted into this square. Bother, it's still resisting. So I've done I, I've done JG, I've done H. JB, what's JB equal to? 30. Oh, and that's a 9. That can't be a 6. That's got to be a 7 or an 8, therefore. This has got to be a 7, 8 or a 9. These 2 squares have got to add up to 12. There we go. So this is 7 and 5 now, because this can't be 8, because that would plonk a 4 here. So 7, 5. That gives us an 8, 9 pair into those squares. These 2 squares are 4 and 8, which is now resolvable. That gives us a 4 here. Look, this must be a 5 or a 7. That gives us a 5, 7 pair in row 7 of the grid. So these 2 squares have got to be 1 and 2, which is resolvable. 2, 1. HB is equal to 10. Good. So HB is 10. It can't be 2, 8, 3, 7 or 4, 6. This is 1, 9. Now, is that useful? That places a 9 at the top, look. These 2 squares have got to be 6 and 7 now. That gives us the 5 here, gives us a 7, gives us a 5. This is an 8 by Sudoku. This square here has got to be a 7, unless I've made an error, which is possible. That's an 8 by Sudoku now. Okay, and 6s, this is 6, of course that's 7. This is a 7-3 now, that's nice. That gives us a 3 and 1. That gives us a 3-4 pair, look, in this column. So this has to be an 8 or a 9. Now, have I used up all of the constraints properly? Oh, I haven't actually resolved. JB was 30. So that's working. At least that's showing us it works. 9. And so there's a 7 cell overlap adding to 30. The way to check that is to look at the last 2 digits and check they add up to 15. And they do, because we know the column adds to 45. E in this one is 6. So this is an underlap. Oh, bother. It doesn't do anything. So it's an underlap of those 2 squares. Again, it's sort of confirming we haven't actually made an error yet, but it's not actually helping me to solve the puzzle. Now these squares have got to be 1, 2 and 4. So let's plonk those in. 1, 2 and 4. These squares have got to be 5 and 7. Oh, that's also unresolved. Let's check everything is reaching the squares it's meant to reach. Wasn't there a green cell somewhere? This square was green, I remember. That's disappeared altogether. That's a 5, but it's also a green 5. Now it's changed colour. I don't know what's going on. So these have got to be 7, 8 and 9 in some order. That's not 8. This square is a 5 or a 7, and G adds up to 9, doesn't it? So this can't be 5 because the 4 would clash. Nice. So that's a 7. This is a 5. This is a 2. This can't be 7 anymore, which shunts the 7 up the top there. The 1, 4 pair, I feel like that should be resolvable. Maybe there's a clue I've not used yet. I think, oh, that one. That's a 7. That's a 5. Eight, 9 here means this is a 1. That gives us a 9 there. 9 and 3 get resolved. 3 and 4. 4 and 1. 1 shifts up there. Okay, so we're nearly there, but we're still not quite there. This is an 8, 9 pair, so the 5 and the 2 go in to the centre. And there must be a way of resolving this. What is it? Ah! Oh no, have I made a mistake? Is it the... Oh no, it's going to be this HJ clue. I've not looked at this one. 1, 13 with a 7 and a 4. So 4... Oh yeah, it is that. That's lovely. What a lovely way to finish. So these 2 squares I've got to add up to 13, which means I can actually get the 8 and the 9 resolved. 8, 9, 9, 8, 9, 8, and that's what I'd submit. Now the check function won't work because the grid is it's sort of an 11 by 10 hybrid grid, and our check function is naive anyway. All it's checking, even on a standard Sudoku, is that the rows, columns and boxes all contain the digits 1 to 9 once each. So hopefully my solution will be correct. No doubt in the comments we'll hear if it isn't. That's certainly what I'd submit. Loved the puzzle, Carrick22, and yeah, I hope you guys enjoyed the Enigma Variations. See you soon.